Привет, ребята, как дела? That's the extent of my Russian.
Not bad.
But I do understand quite a bit more, so if you're gonna diss us, do it in language that I can't understand.
Oh, wow. И несмотря на то, что я вырос в Питере, большинство своей профессиональной деятельности мне пришлось провести в Северной Америке, поэтому презентация будет на английском. Не из-за моего русского, а в принципе из-за русского Мартина. Но вопросы мы принимаем на обоих языках.
Well, he can take them in Russian and translate them to me if I don't understand.
All right. So why are we here today? Database refactoring. Tough, fact of life in most applications, and very difficult to do, right? Especially if you're trying to do things like continuous delivery or continuous delivery at scale. We're going to talk about a use case of an application that Martin and I have worked on and put together this process that has about 6,000 tenants, and the way the multi-tenancy is done on this application, and we're not going to go into the religious debate of different ways of doing multi-tenancy. We have a single schema per tenant, right? So we have 6,000 schemas under management. That creates quite a challenge sometimes. But more on that later. One thing we do both have to say, having been employed by Oracle Corporation for a bit now, that the opinions in the stocks are ours and nobody else's. We do not represent Oracle as a company with anything we say in the next hour.
So, what we're going to do today is break this presentation into two pieces. Well, we'll start with the customer introductions. We'll tell you why we think we're qualified to talk about this topic. And then we'll jump into the fundamentals of database refactoring. This is going to be a little bit of the dry theory with some light examples. And then we'll jump into a case study, which will analyze how we've done this at the application level using the example Leonid has already mentioned, and then we'll hopefully have enough time for Q&A. So let's start by introductions. Well, Leonid is based in California. He's been a Java developer for over 12 years. He's been doing SaaS for, well, before it was known as SaaS. It was.
We used to call this thing ASP, Application Service Provider. SaaS is a way cooler name.
And in addition to that, well, he speaks few languages: Java, Scala, Russian.
Touch of Hebrew,
some Polish by now, right? Having visited Krakow quite a few times.
After Zubrovka.
Yeah. Oh, look, some people know what it is. Excellent.
Amen.
And he's an avid traveler and photographer. I'm surprised he doesn't have a camera with him right now to take pictures of your faces. But he's got an iPhone. No? Yeah.
That's somewhere here. So Martin actually used to be in North America, now is in Poland, went back to the homeland. Also been doing Java for many, many years, and Martin and I have been working together actually on a number of apps for a number of years. So 10 years of SaaS experience. The important thing to know about Martin when it comes to this presentation as a context, Martin hates SQL. Absolutely hates SQL.
With a passion.
Now, the funny thing is, you know, DSL, Scala, DSL languages are all the rage now, and people forget that the most popular, the oldest, that's a good English, the oldest DSL language in the world is probably SQL, right?
Stary, да?
Stary, you see? So, now that you heard a bit about us, let's find out about you.
Get into finding out about you, because we may have to tailor these presentations a little bit depending on who's in the audience and which jokes we can and cannot crack. So, are you a developer?
By a raise of hand. All right. Whew,
I think this is kind of, we don't need any more answers. But
well, let's find out.
Let's roll through it. Are you a DBA, perhaps?
Yeah, man, no DBAs and all the jokes go. We actually did this. We did this talk in Krakow. There were like 3 DBAs, and we're like, damn it.
This is the first time when there's not a single DBA in the audience.
We'll talk about them a lot.
Are you a DBA? Leave.
No. Martin, shame on you.
Do you write your own SQL, and do you write, well, actually, no, let's start with, do you write like... Well,
complex SQL.
Do you like writing complex
Who
SQL?
likes writing complex
SQL? Who likes SQL? There's 1, 2, 3, 4.
Strange people in the audience.
Strange folks.
Strange.
Hey, you know, they're probably making good bucks making this. Do you maintain your own schema, and do you write your little schema changes that get applied to production?
As an app developer, who's responsible? All right.
Okay, so
then this talk is for you then.
Most likely. Do you use a tool, perhaps, like Play, Spring Brew, or something like that?
Does it work well for you? Yeah, so is the answer.
So we thought.
All right. Database refactoring. We're not going to cover a lot of the fundamentals. There's a lovely book on the subject that actually, much like the original refactoring book, talks about all the standard patterns, gives you the play-by-play, step-by-step instructions on what not to do, what are the considerations, what are the trade-offs, but we'll show you some. Before we get into the samples, when I think about refactoring, we as a human race, we've been refactoring stuff for many, many years. This is a picture from a trip of mine to Guatemala last January, and this is a Mayan temple. For reference, there's like a human being right there in the corner, so this thing is about 55 meters tall. The funny thing about those Mayan temples is the way they're being built is traditional refactoring. They always start with a small hill, and every baktun, which is a Mayan word for, I can never remember, 12 or 13 years, they will add a layer, and another layer, and another layer. So inside of this temple, there are like empty chambers, rooms you cannot reach, that code, wait, that's software systems, right? Sounds familiar, right?
Skeletons.
Skeletons in that thing. Our databases quite often evolve in the same fashion, right? And it's even more difficult to do them. And Martin Fowler, who wrote the original refactoring book, and who here has read the original refactoring book? Not enough people. If you traditionally working on normal software, you must read this book. Has identified the problem with refactoring databases even when the original book was published. And quite often he said, not only the databases are difficult to refactor because there are sometimes no tools, but sometimes also because the database professionals and the software professionals don't really live together, right? They don't in the same organization, quite often don't talk to each other, and quite often they think about different things when they do their daily job. So that's an important impediment to remember because we're going to be talking about some things you can do to address that. But human element is not to be underestimated in the challenges when it comes to database refactoring.
And in the context of the database, that human element is quite a bit larger than in context of source code and refactoring source code. Because with database, there's a lot more stakeholders. Source code, you own the source code. Whatever you change in the source code, you're responsible for it. However, when it comes to database, there's a lot of people that do own this, right, the database. So first and foremost, there's developers who use the database. You guys code against it, so you're stakeholders. Then there's these pesky DBAs, right? The folks that we don't know what they really do. They do something.
They say no.
Yeah, they claim to be, making sure that the database runs fast, that there's enough space for the logs, although we constantly run out of space. And they're really, really interested in anything that you're gonna do to a database, especially if you start changing stuff in it. Another group that commonly I've seen using a database is the QA departments, right? They most likely have some seeding scripts, some testing scripts, something that runs automatically that does depend on the database structure, and any change that you introduce will affect them. And last but not least, there are the business analysts, right? Those are the folks that may have some very, very complex reports built against the database, running against the database, and anything you change, refactor, will potentially affect their work. And it's very important to understand that these guys are stakeholders, and anything you want to change, you're gonna have to run the decision through some of them, and you're gonna have to get them involved and most likely convinced that what you want to do is necessary. However, that's not always easy. Here's a quote from one of my favorite scientists, and it basically says that the fact that something is true does not mean that everybody's gonna accept it, and sometimes it'll take some time for the opponents to die.
And we do not by no means suggest you go and do anything to your DBAs at the company. But please don't take it that way.
But I'm actually very hopeful that we've been dealing with databases long enough that the real opponents have already naturally kind of died, and the new generation doesn't understand. They got promoted. Or they got promoted to management and are no longer a problem, just like us. And then the new generation is here, and hopefully that will move things forward when it comes to database refactoring. But it is hard.
But there are tremendous benefits to be gained, right? One of the most difficult things to do with databases is designing a data model up front. Quite often we work on applications that support a business, and pesky nature of businesses, they evolve, right? Requirements that show up in a year from now are not the requirements you could have anticipated and predicted today. So quite often it makes it very impossible. Knowing how to involve the model quickly and effectively will give you the flexibility to keep up with the business while still staying happy with what you see in the database, because also quite often you have things we call database smells, right? The refactoring book introduces this notion of code smells. Those are the things you look in the code and that kind of tell you you really want to look at that area of the code and do something with it. Database smells come in different varieties. We're going to mention some here. I'll go back. And they also not always an anti-pattern, right? And every anti-pattern can be applicable. For example, Martin and I work on heavily metadata-driven applications where multi-purpose columns are okay. We never would write a zip code into the same column we write a phone number to. But quite often we have metadata that describes what is stored in certain areas, right? Too many columns has an interesting story. One of our former colleagues worked on a very popular blogging platform, we shall not mention, that was using a Postgres database underneath. And the funny thing about the Postgres database is it uses a pattern called MVCC to implement concurrency. And every time you update anything in the row, a snapshot of the row is being taken, a new row is being written, the older one gets marked as unused or maybe used by some other transactions. And then early in Postgres days, there was this thing called vacuuming. It's kind of cool. You have to vacuum your database to reclaim that dead space. Not anymore, but in that particular platform, one of the columns in a table of 100 columns was last accessed date. So every time somebody would make an HTTP hit to a blog article, we would clone the entire row, including the description and the content of the article. Fun times. So they've used one of the refactoring patterns to get the stuff factored out and properly normalized away so this does not create the performance problem.
Right. So having covered some fundamentals, let's get into specifics and the mechanics of database refactoring. Let's start by defining what do we actually mean by database refactoring. And this definition is a very handy one, and we like it. It basically says that refactoring is a simple change to a database that does not change its design, and it retains, is a database schema that improves the design but does not change the behavioral and informational semantics. What I really want to highlight is this little bit, simple change, because the simpler the changes you're going to make at one given step, the easier it'll be to apply it. It'll take probably less time to run on a database. It'll produce less log. It'll be much easier to roll it back should you ever screw up, and you will screw up.
That never happens, ever.
No? Okay. Maybe to this crowd of geniuses, but it does to me. And then it'll be also much easier to review. So, you don't want to apply anything onto your database that you haven't reviewed, and if it's a little small change, it's much easier to understand what it does and review it. Now, how do you go, excuse me, how are you going to go about applying those changes will also depend on the application architecture type that you're dealing with. You could potentially be in this scenario. I'm actually very curious who is in this group, and basically what I mean by this scenario is that you have an application that runs against your database, and you own and you are the only user of both ends. So
one-to-one. Any lucky ones in the room? Yay! Yeah. 6, 7. Cool. Wow.
Cool. That means your job of refactoring databases just got considerably easier. However, I think most of us are in this particular scenario. You could have an application that you develop that runs against the database. There could be another application that someone else develops that runs against the same database or portions of it. Or there could be another application that you don't know that runs against
the friendly DBA.
Database.
They just gave somebody creds and said, that's okay. Just write into the same schema.
And on top of that, there could also be a number of other integration points that will affect anything that you need to change.
All right. Key steps. So when you think about refactorings, you're typically going to go through a particular sequence of steps, right? One, and probably most important, is agreeing that the change is needed and also agreeing with all the stakeholders, whether those are the guys from QA that maintain the data load scripts or the guys that author complex reports. Then you're going to apply one of the patterns and refactor the schema. You're going to migrate the data. And at times it gets pretty tricky. Quite often you will apply refactoring to data stores that have millions, if not hundreds of millions of rows. You have to refactor your external access programs gradually, starting with at least one. Run your tests. Who here has a database test harness for the database? Anybody? Yeah, I thought so. There's a lovely talk right after us, after the break, on TDD for databases. I strongly encourage you to go and see it because it will cover a lot of interesting TDD patterns for databases. Now, quite often you will run your tests then, if you don't have a harness, you will run your normal automation test, your application test, your integration test. So you will exercise the database through some other test harness. But it's also important to understand that you have the coverage for what you need to cover. Version control the change, and we'll talk about that more. Announce the change to consumers of your applications, deploy to production, and eventually when you go through this period of backward compatibility, you're going to deprecate the old schema, right? Because you have multiple applications going against the old schema, since we're trying to refactor it, we have to maintain the informational semantics of the schema for a while until we're ready to change it completely.
Okay, so now we know what a refactoring is. Let's talk about a little bit more about what types are there. And they are quite well categorized. The book talks about it. First category is the structural type. These are, as the name implies, all the refactorings that do change the table structure or you know, moving a column from a structural change. So moving a column from table to table is an example of such refactoring. Then you have data quality refactorings. These are things that you would do to your existing data to make it of better quality. So as an example, you could have a phone number that is stored just as regular, you know, numbers, and you, for some reason, wanted this to be formatted. You'd basically
Or we now need to store international numbers.
Or we need to do something like that. So massaging of the data to improve its quality. The third category is referential integrity. These are changes that you make to ensure that reference rows exist in another table. And anything that basically any sort of referential integrity introduction are examples of refactoring that needs to be done. We've seen some databases where, you know, there was zero referential integrity.
We are big believers in referential integrity. We're also big believers in this pattern called fail fast and fail early. More on that later.
The next category is functional. These are changes to anything like stored procedures, functions, and triggers, should you have any.
Who here is fortunate enough to have a lot of stored procedures?
Triggers.
My condolences.
Triggers, maybe? Yeah.
Triggers? We love triggers. They're so implicit. They're awesome.
Business logic and stored procs.
Although, we'll talk about triggers and how they can be actually quite a handy tool when it comes to refactoring.
Okay, and last but not least, there is the Non Refactoring Transformations. Those are changes to database semantics, like adding a new column to an existing table.
Try saying that fast 3 times.
In Russian. So what are the most common structural refactoring types? Well, replacing a column, dropping a column, renaming table, renaming column, few other that are most common, and many, many more that do exist and are not, maybe not that often used, but are there.
The ones on the left are the ones we see commonly used in our applications. The ones on the right are well documented as well in the books, but we just don't use them as frequently.
So we'll jump into one example. We'll tell you how renaming column works as a refactoring. And before you actually do any refactoring, you're gonna have to figure out, why am I doing this? A motivation, like why am I actually trying to do something that can potentially upset a lot of people? So in terms of, in case of renaming a column, you're probably improving the readability of the schema. Have we seen tables with columns called XYZ? Yes, we have. That doesn't make sense. Sometimes you need to improve the readability. Or you're trying to port the database to another, port a schema to another database where your column names that you've used are restricted keywords in this other database.
Oracle.
So, next thing you need to figure out is, what is the cost of doing this operation, right? In this particular case, your cost is whatever changes you need to do to the application versus what kind of readability you're gonna get out of making this change. If you're using ORM and you're renaming a column, you'll most likely have one little mapping file to change. But if you're using JDBC, straight JDBC, God knows, there could be hundreds and hundreds of places where you actually have to go and change the column name. Not that hard with today's tools, but a lot more risky. All right, so you've decided that, motivation is right, trade-offs are acceptable, let's do it. So how do you actually go about doing this? Well, you first introduce a new column with this new name. Then you will add the syncing trigger that we've already mentioned a little bit. Leonid was talking about having to have the same semantics for a particular period of time. That syncing trigger will allow you to do it. So what it'll do, and we have a very specific example in a second, what it will do, it'll keep those two columns in sync. And then you consider renaming their referencing columns. So if you have anything referencing that column, for the sake of readability, you probably want to also rename those, because that's what you're getting at. Then you're gonna have to do the data migration, right? So you're gonna have to migrate the data from old column to a new column. And data migration is a topic of its own. And the book that we've mentioned actually covers a whole bunch of excellent data migration patterns. So it's a separate topic in its own. Here's an example of what I was talking about. So we have a customer table, and it has a ID and a F name, right? F name probably stands for the first name, but
you never know.
It isn't obvious. It could be some other F name.
Gotta love working on somebody else's schema.
So what do we do here? Well, we first introduce the first name as a new column, but we're still keeping the F name around, and we're dropping in that trigger I was mentioning. The trigger will basically keep both of those columns in sync on any sort of data change operation that happens to either one of those columns. This gives us the compatibility for various apps during the transition period. Once the transition period passes and all the other applications that are using this schema are, have adjusted, the only thing that remains is to drop the F name, and you're basically all left with a nicely renamed column. I've mentioned data quality refactoring types. Here's some most common ones, most often used, that we've implemented and done a lot, but there's a whole bunch of other ones. Similarly, with referential integrity, there's some of the most common used, like adding a foreign key constraint or soft delete, and a few other ones. One of those here is particularly dear to Leonid's heart, so I think he'll...
Oh boy, it is. How much time do we have left? We have time
we're
for
22 minutes in.
All right. So, cascading deletes. I have two words for that. Evil and evil. And I'll tell you a story. I was a junior engineer, maybe about, we won't talk about how many years ago. A while ago. I was sitting in front of a production database with a shell open to SQL. And I needed to, for a customer, I needed to clean up a couple data records from that. Little did I know that there were cascading deletes in the schema, so I typed my delete statements, I pressed enter, and I waited. And I waited. About 4 minutes in, I decided that something wrong is going on. It is a production database after all. It's a powerful Spark machine at the time, right? So, of course, I hit Control-C. Unfortunately for me, I was within a transaction, so I didn't really completely destroy the data. But what I found out is it was a directed graph stored in the database with cascading deletes, and I accidentally tried to delete a top of the graph. So the rest of the database gently and gingerly started to wipe itself out. Awesome! I would have been, they'll probably not fire me, but it would not be fun. That would be a joke of the entire
You'd
team.
be a butt of the joke.
So,
for
cascading deletes, don't use them. Implicit stuff in general in the database. There's a lot of stuff databases can do implicitly. Some of those are good. Data quality validations, good. Constraints with column format validation, awesome.
Indexing.
Referential integrity validation, great. I think we'll talk about this here, right? Having a referential integrity allows you to not only fail fast and fail early, and those of you that seen my previous talk, I talk about being on call in the middle of the night, 2 a.m., getting a pager after a night of heavy drinking and trying to have to figure out what the hell has happened. Databases have this lovely feature called deferred constraint validation, because writing data in order can be difficult sometimes, and we can just say, hey, set deferred constraint validation true within the transaction, and database will check the constraints at the end. Well, it creates a tiny little problem. And the problem is, you get the crash when you execute the commit, right? You may have written data over here somewhere, and then over here, and over here, and over here, and then eventually the transaction has finished, and the transaction manager goes, commit. And you get this lovely exception stack trace that takes you to the transaction manager in the middle of the night. Not what you want to see. Use the constraint validation. Leverage your database, not only because it helps you troubleshoot the issues, it also will help anybody who writes to that database directly, DBAs, not to write any type of data into the database that you would not want your application to deal with, parse or not parse, and crash. They do that on occasion, those DBAs.
Those DBAs, right?
All right, testing. There's more on the TDD for databases, but we'll quickly cover the stuff you need to test. You have to test store procs, You should be testing your referential integrity, especially things like order of insertion. View definitions may need to be tested if you change the semantics of the schema. In some databases, materialized view requires special attention if you need to destroy them. Default values, if your app may be relying on them, if you remove them or add them. And the data invariants also have to be tested because somebody can screw up the implementation. And then most importantly, you have to test your data migration testing. Most of us work on applications where code is cheap to change. We can roll a code, especially if you have continuous delivery, you can easily fix the code and move it on. If you just screwed up customers' data on the live production environment while it was running and you have destroyed it and the system is still running, there's no restoring from backup. Or if you are restoring from backup, you just lost hours of customers' work. And those customers, they tend to get upset about that. I don't know why.
They call, right?
They call. And you know, we engineers wouldn't like talking to them. So data migration testing can be very, very tricky, and needs to be tested. All right. Let's talk about how did we put it all together on an application. So Martin and I used to work together until he left us for colder Poland on this application that has about 6,000 tenants, which means 6,000 databases under management, 76 million transactions a week, average response time about 170 milliseconds. May not be relevant to the database refactoring, but it is. Peak transactions volume at about 20,000 a minute, and then average transaction volume is 5 to 7. The reason this is important comes in the release model. So we are multi-tenant, so single code base. Every customer runs it with favorite configuration over customization. We release to every customer, and when my friends ask me, do you love your job? And I tell them, yes, I love my job because I get to give all my customers, all of my new features on the same day. But there's one little tricky thing. We also give them all the same bugs on the same day. And boy, do they call. We have nearly zero downtime releases, so they're very transparent to the customers 95% of the time, not related to database refactoring. We do have a point of no return in our release process. Who here believes they have a rollback strategy for their releases? By the raise of hand. Smart bunch, man. At least they're not deceiving themselves to think they have a rollback policy. We don't believe that rollbacks work. We roll forward. We do have a point in our release where we know we cannot roll back and we have to move forward, but we have some flexibility. Releases are done under average transaction loads, right? We do a lot of our database refactoring because it does take time while the app is running. So we do it live, which is the coolest thing ever because it reduces so much stress. And obviously customers are happy that we don't have to tell them that, hey, this Friday evening we're going to take your applications because we have some data migrations we need to do and you'll be down for 36 hours. Call us later. Typical release has about 70 to a couple hundred individual database changes, right? We move on the schema and we release every 8 to 10 weeks. Apply this to 6,000 tenants, 500,000 changes overnight, easily. What do we do to support ourselves? First of all, we manage all database artifacts and source control. Nothing allows us to refactor more reliably and more effectively, and I've seen so many organizations where the code lives over here, and then this whole schema SQL stuff, yeah, who cares about that? The DBAs can deal with that. We don't need it, right? We have everything in source control. We have the change scripts in source control, which allows us to assess the impact of the refactoring very, very easily. We also apply standard basics of source control management, you know, the branching, merging, rollbacks, all the stuff that the DBAs are still learning. Obviously, we have the OR mappings in source control, all the stored procs, if you're unfortunate to have them, and all the triggers if you're using them for your refactoring. And all the data migration scripts. We asked the QA team to kind of leverage portion of our repository so at least we can assess what is that we're going to break if we decide to make a change. Test data generation scripts as well. So, a couple acronyms that we will be using. DDL, data definition language. Those are the scripts that we separate that talk about the structure of the database. Create, alter, drop, truncate, rename your structural stuff. And then we have DML, insert, delete, update. We have an automation. We have a set of automation tools that applies them to all of our environments, and they're treated differently, and you'll see why.
All right. All refactorings are split into small incremental changes, and here's how we go about doing that.
This thing deserves its own slide, right? It's important.
It's important.
Small changes.
Divide and conquer. So we have the following naming convention for our scripts. Each of the scripts gets a file sequence. They get run by automation tools in sequence. They have to be sequenced when they're created. Obviously, sequence is important because you need to do certain things before other things when you're changing data structures. Release number is just a number of the release we're working on. It's here mainly for the fact that when we take some script out of context, out of the repository, or God forbid send it by someone to email, well, at least we know what release number this belongs to. Project name is also internally used by our various teams. We have a number of teams that work on projects simultaneously, so this is for sanity's sake. They know that, again, taken out of context, this particular project belongs to, this particular file belongs to a particular project. And a brief description, this is meant to, be something like insert this, or, like a little blurb that tells me right away what kind of a file is it. Very handy when it comes to reviewing stuff, because you may want to concentrate on DDL more than a DML. This will help you. And the aforementioned by Leonid DDL, DML suffix, which is again used by our automation tools. Here's a snapshot. Here's an example of file naming, real stuff that we have in the repository. And an interesting thing to notice is that we basically skip the numbers by 10. So we have 110, 120, 130. This gives us an ability to insert scripts in between here. Why this is important is because in our development model, it takes an act of God to change the script or to remove the script once you've committed it into a database. Into a repository rather, sorry. Once you chuck the script into a repository, it may automatically, very quickly get picked up and run against various different environments. Development, QA, potentially staging in later phases of development. So we want to avoid taking them out, because there is a huge potential for inconsistencies between how the scripts were run in various environments. And there'll be a little bit more about inconsistencies, how we deal with those, but it's important to remember that no taking out of the script is possible. You should write an incremental change that fixes what you think is inappropriate or what you broke. And, so far in our experience, the 10 spots we had, never had an issue. We didn't have to do this. That many scripts. Another thing that we enforce in our scripts, is that each one of them follows a particular template, and part of the template has author, project, and description. Author, project, kind of obvious. Description seems to be is here to be a lot more verbose and tell us exactly, well, maybe not in an essay form, but in 2-3 sentences, what and why this script is doing. This is incredibly useful when you're doing a review of SQLs and you have 100 files to go through. We also make the scripts safely rerunnable as much as we can. Pretty much all of them can be rerun. We have 2 standard methods of doing this.
We'll probably have more. Those are just a couple examples.
Those are the most common. Okay, so we use the run script table, which I'll talk about in a second. But basically, is a run script table that it holds an information about every single script that's been run against this particular schema. Or we sometimes also just ask developers to look into a particular table and identify whether an operation can be done or not. So in this case, we're trying to drop the column. We'll check if it's not there.
This rerunnability of those small incremental changes becomes paramountly important when you start rolling stuff to production and it starts breaking, which on occasion it does.
Here's the aforementioned run script table. So our automation tool writes into this table, and this is how we know what exactly has been run against each schema, and actually who has done it as well, and when.
It's awesome for blaming people.
It's used for blaming people, but it's also very, no it's not, but it's also very useful when you actually need to figure out, if something crashes and you need to either pick off from where you've left off, or you need to figure out what exactly has been run and what exactly has not been run. Some common DML patterns that we've came across while developing a lot of scripts is, and those are things to be careful. Avoiding bulk updates. If you have 1 million rows in a table, don't try to update them at one go. Use a cursor to do it, and use periodic commits.
Yep, because if it failed on row 900,991, you don't want to rerun it again because it just takes time.
You want to create and use a library of reusable templates for common tasks. We've noticed that a lot of the stuff that we do is repetitious. Like we're adding columns, we're doing that. But it's kind of same thing, just on a different table. Create a template. It'll be very easy to review later on, and it'll be also a good learning experience for new people, new developers. You'll avoid mistakes.
And for those of you, which is the majority, who don't writing SQL, it just minimizes that pain, right? You grab the pattern, you fill the blanks, you're good to go.
Oh yeah, that's true. I forgot about that. We also started backing up our data pretty religiously. So whenever we change something, we create a backup table with the release number, and immediately we create a script that will drop that in a future release. So for a while, we have these two tables. One is backed up. This gives us an ability to recover the data should we really screw up, and sometimes we do.
We don't back up, obviously, the entire table. We back up the column or the data set we just affected with a particular data migration. It helps tremendously if something was applied to the database a few days ago, and now the customer is complaining that we may have destroyed the data, and you need to go and recover it. Recovering it from a backup is very difficult, because by the time the backups got restored, you have to merge this. This lives right inside the same schema, and we have an automated tool that picks them up and deletes them after a certain period of time.
So that's the next bullet point. And even though we like to joke about the DBAs, in all reality, a good DBA can be a lifesaver, right? That person really, really knows the database. And we've seen that, you know, some complex scripts that would run for 10, 20 minutes on a large table, a DBA would take a quick look at it, tweak it, and all of a sudden we've shaven 90, 95% of the time that the script runs. So yeah, they're pesky, but they're not nice. They know their business, so use them. Here's an example of how we store our SQL files. So we have a release folder. So this is out of repository, of course. We have a release folder. Within the release folder, we have various versions of the release, and we have component names because our application is comprised of many components, and they all get to use the database or various databases. And within each component, we have 3 folders: pre, main, and post. So what goes where? In pre, we put all the scripts that change the database in such a way that it's still backwards compatible. So by this I mean we can run all those pre-scripts, the old code is still running, and nothing happens. Everything is nice and dandy. And a quick example would be adding a new nullable column to a table. Then we have a main folder in which we put minimal changes that are required to make the schema compatible with the new version of the code. And that particular set of scripts, when they are run, they require the database, or the application rather, sorry, to be down, right? Because obviously you cannot modify stuff that, you know, database is not aware of yet. Application rather, sorry. And then we have a post. And in post we put everything that, all the changes that do require a new code to be actually applied. And what we found ourselves doing with this is putting a lot of seeding and a lot of metadata information that drives our application.
That's right. Now, you have to have some certain features on your application, because in some cases, until post completes running, some new features are not available. There's an awesome talk called Feature Bits from the guys at the company called Lyris that talks in very, very much of detail on how to do that.
Speaking of talks, before I forget, there's also an excellent talk by Martin Fowler and the guy who wrote the book, which I forget the name right now, which talks about this stuff as well. All right, here's a snapshot from our repository. An interesting thing to notice here is what I was talking about before. So somebody wrote a 100 script, and then somebody wrote a 110 script, and then we realized that we need to revert some of the changes. So this is how it would look in the repository. SQL review. So this is a process that we've implemented pretty much at the beginning of this entire roadmap. So what happens is that every change gets reviewed by multiple senior developers. So throughout the release, we repeat this, right? And we wait until we amass a certain amount of scripts to be able to sit down and review them. We do this, as I said, throughout the release. And because we version our code and our database changes as well, we get to use the standard tools that we use for code reviews. So in our case, it's Crucible, but you know, you're free to use whatever other tool you have.
Yeah, those reviews are extremely important. In our case, every single SQL change gets reviewed by more than one engineer. It's expensive, but it's even more expensive to screw up the data when you go to production. As I said, continuous delivery, fix the code, compile, build, test, deliver. Recovering from a botched data migration is very expensive. So the way we apply this to all the environments, dev, we apply the automation, or we'll apply the changes as they roll into the source control. QA, we have less frequent pushes, and they will go there. And then obviously there's a highly controlled deployment to production. Now, the problem with this is when you write pre, main, and post before, in the middle, and after, sometimes you have to apply them out of sequence, right? And they get applied out of sequence on QA, but they are applied in sequence in production. So we have a process that helps us mitigate that. So as a developer, you will create your change. You will release it to dev and QA, right? End-to-end. Automation tools. The moment you committed the code, our automation tools will pick it up. Then we'll go through a SQL review process, and then we'll do a final integration test, right? Release and do the post cleanup. The backup tables get removed, etc. So, as an example, I wrote 10, 20, 10, 20, 10, 20 scripts in pre-main and post, rolled them down to QA, and then somebody else wrote 210, 220. The problem is, 10 and 20 post has already been applied when we're rolling out 210 and 220 pre. So they do get applied out of sequence in those environments, and this continues throughout the release. So in order to mitigate this, we run a final integration test.
It can cause problems, right? So occasionally we can do something that does cause problems, but it's extremely rare because most of the time you're making changes to a table that you're working with. Very rarely someone else is working on the same story or the same bit.
But to be safe, we have a final integration environment which always has the master copy schema of the database that is running in production right now. We'll run the pre-scripts. Guess what? We'll do the TDD stuff. We'll run some tests. Then we'll run the main scripts. Deploy the new version of the app. And by the way, with the pre, remember the app still has to, the old version of the code still has to work, right? Then we'll deploy the main and the new code, and we'll run another test because the new version of the code needs to be able to work without the post scripts being completed, right? Another regression test. Then we'll run the post, and then we'll run another regression test. In our environment, it takes about a day to kind of go through the sequence in the pre-release stabilization. On the day, a week of the release, we'll run the pre, we shut down the app, we'll run the main, we deploy the version of the app, we run the post, run cleanup. Now, we will start running pre, and we have predicted, we can predict based on our history how long the pre will take. We can start at the day of the release, but because it maintains the comfortability of the schema, depending on the amount of data changes we need to make, we will start it sometimes 4 or 3 days ahead of the release, sometimes several weeks ahead of the release. Similarly with post. The post may not complete immediately after the code is rolled out. It may take us a week to do all the data migrations. The only thing it means to our customers while they use this app is those new features that the new code brings are not available until we finish the migration. Now, at the beginning of the talk, we told you this thing about zero downtime, and then we're talking about this whole main, shut down the app, main can take hours, deploy. Sounds strange, right? Well, that's how we started. Over the years, we figured out that really main is obsolete. We figured out, but by writing a bit more SQL, and although we hate it, that's why we use patterns and reusable scripts, you can ignore the main, you can just run the pre, and some of our scripts are now split. Some of the stuff we would use to do in main that breaks the backward compatibility now gets prepared in pre, and we try to do as much as stuff as we can in pre, and some of that stuff will go into post.
And actually in this particular problem, it was a journey as well, because the stakeholders, that is developers, like myself, who hate SQL, we're quite opposed against writing 3 scripts instead of 1 script, right? It really does take effort, more pain, mental effort, more reviews. But once we started rolling this process out, and our releases went from, starting at 10 p.m., running till 4 a.m., to literally doing them now in 15 minutes from a distributed environment. Nobody even comes to the office to do this.
Yeah, and the amount of stress goes down. Because remember, our scripts are repeatable. Something fails on production, well, who cares? The app is still running. Customers don't know about that. So we're not stressed, oh my God, the app is down. We're about to blow through our SLA agreement with the customers because the app is going to be down an hour and 5 minutes, not an hour exactly. Right? The amount of stress that we took out of the system, that because we can run the database changes. And by the way, when you have 6,000 database under management, stuff will fail. And we'll talk about that,
and
actually.
The stress makes you lose hair. So,
you see how calm I am?
Yes, you're the calmer type. So the common issues that we came across while doing that, we've run into schema inconsistencies. 6,000 databases, they're bound to go out of sequence a little bit.
Sometimes our friend DBA will restore the schema from the backup because somebody asked them to and forget to apply the change script.
So occasionally we do some reviews and we do some analysis on schema inconsistencies. Similarly, data inconsistencies, very much the same reason. There was a little bit of a code running here for a bit that inserted something that didn't belong. We do run into these issues, and this is part of the reviews that we do, or not reviews, but...
the recovery, but again, We run into this on one customer. By the way, since the scripts are rerunnable, we don't even think about what failed in the sequence of 100 scripts. We just go take this sequence, run it again. We know it's safe. We don't think about it. We don't try to figure out where did it fail if it wasn't one big SQL script. We just run it.
And we also have an ability to take that particular customer out of the release cycle and do this later.
Yep.
If it really is something bad. We've run out of transaction log space. We do quite a lot of changes, and it turns out that they produce a lot of log space, and we have run out of it.
It's not infinite, huh?
It's not infinite, no. We've also run into issues with execution time. Something that runs on the development machine in milliseconds may turn out to run for quite a bit longer on a larger data set, even though the data set may not be that much larger, but it does happen.
That's the opportunity to, again, make friends with your DBAs.
So what have we learned? What are the things? Well, we learned to document our schema change process. I hate documenting stuff in formal ways, but we do have a very, very nice wiki page where all the change processes are documented. Serves a purpose because we can very quickly point someone to that, and they'll very quickly pick up the way of doing this. Manage your database, artifacts, and source control. I think we covered that in great length. You just need to. You're gonna lose stuff otherwise. Have your own version of SQL policeman. So I've mentioned the review process, and in every team there is someone who, unlike me, likes SQL. And we found a gentleman like that in our team, and we empowered him to be the SQL policeman, to go after us, make sure that we do our reviews, make sure that we follow the procedures. And the guy has an eagle eye. He can spot a semicolon missing in like 200 lines of SQL code. Not that we would have 200 lines of SQL code in one file, because small changes.
Those of you that are Seinfeld fans, yeah, some of the team members call him the SQL Nazi.
Based on a soup Nazi, right?
Yeah, but it works.
Develop reusable templates for DML, DDL. Again, don't reinvent the wheel. Someone has already done it in your organization. Use the templates, much easier. Have repeatable automated process. Very important, because you want to make sure that whatever runs on your dev and QA and staging is exactly the same flow that's going to go on production. Only then you can ensure that you keep your sanity on the release day. Make a friend out of your DBA. They're great. There's none here, but they're fantastic people when you can actually,
when they can help you.
When they can
help you.
And they can, definitely.
All right, key messages, guys. This stuff is hard. It's much harder than the code because the tooling sucks, because people don't like SQL, because there's organizational divides. Automation and repeatability, in our experience, are the key. Review and everything. As I said, we have probably over 300% review coverage on SQL.
Easily.
Multiple engineers look at every single change script because the recovery is so expensive for us. Backing up crucial data is something we learned the hard way. Testing, as much as you can reasonably can. And again, there's the speaker in the room, and there's the TDD talk for databases coming up. Very good content. And don't reinvent the wheel. Follow the partners. There's a book. They talk about every single database refactoring you can think about. They will give you the steps. They will give you the trade-offs. You can just simply follow them like a good recipe. Here's the book. There's a lovely website on agiledata.org. We didn't want to use the buzzword in the talk title, but your databases can be as agile as your code. There are a number of tools, DB unit, SQL unit, PL SQL unit, that you can also use for testing. Highly encourage you guys to explore them and use them. And I think with that, we're going to switch to Q&A. Yes?
You told about the automatic management of the schemas.
Yes. So the question was, how do you guys automatically apply schemas, schema changes across the environments? I can tell you that it's a very fancy, very complex tool that we license for millions of dollars. It is not. It's a shell script with a database shell, and a couple helper tables that connects to a source control. It gets a configuration. It knows that it needs to work with this particular branch right now against this database. Connects to a SQL, connects to source control, gets the net new changes, figures out what it needs to apply, and it started as a couple hundred lines of shellcode. Now it's probably 1,000 lines of shellcode because there's some variations. It doesn't take a rocket scientist. You can build one probably in a day or two. Basic loop that loops through the files, runs them through a normal SQL shell.
We should start selling that.
I know. Oh no, we should start a consulting business. All right. Any other questions? We must. Oh yeah. Question 2. So the question is, how do you manage inconsistencies between different environments? And in our case, sometimes within the environment between different databases. Two things. Part of our process is designed to ensure that those inconsistencies don't exist. And it works fairly reliably. Things like, you do not change the SQL script when it got committed because it already got applied. You have to go and write an incremental script. Is it going to run longer on the release night? Yeah, because now you have to do more stuff. Do we care? No, not really, because the app is running. We can do those ahead of time. That's number one. Number two, those integrations tests that we've mentioned, right? We do run an end of the release integration test to ensure that everything is going to work as predicted. Number three, stuff does go out of sync, especially within our production environment. When you have 6,000 schemas under management, shit happens. We have an audit process, and the audit process, when it started, was as simple as automatically dump the schema definition into individual files and write another shell script, if you didn't know the theme here, with diffs, see if there's anything different. We actually, for SQL Server, there's an awesome tool by the company called Redgate. They do a tool called SQL Compare Pro. Oracle has its own suite of tools in the SQL development suite of tools that can do this audit. Again, at our scale, we had to write some of our own automation to do that, but periodic audits are probably a fact of life. But in our cases, we don't discover a lot of differences because of this repeatable, fully automated standard process and because we don't change things.
We've run into some issues initially when we have actually inherited X number of databases that we needed to start working on. But since then, we've kind of cleaned it up, and now is the process.
Yeah, the team that worked on the product before Martin and I came to the team thought it was okay to have a different, it used to be a varchar 5, and then we're going to change it in the new schema to 10, but we're not going to go and update the old ones. Who cares? That created some interesting surprises for us on the release nights. Yes?
Sorry. Can you do me a favor and ask it in Russian so he's forced to, so I can hear his professional Russian?
Okay.
Please. If you speak Russian, that is.
Ну, так у всех проблем бывает. Bottleneck с точки зрения перформанса или с точки зрения релизов? Окей. Стор-процедура — это вообще неправильная методология, но это отдельный вообще ток еще на пару часов. Я могу про это очень долго разговаривать. Это тяжелый вопрос, потому что ответ очень контекст требует. Я могу потом отдельно поговорить, поэтому я не могу тебе так с русским с удовольствием. Somebody else other than the gentleman that asked the question? Martin, are you satisfied? Am I good? Have I passed the test?
You haven't answered the question, but you did okay.
Вопрос был, почему стор-процедура... Ну, например, хотя как представитель компании Oracle, которая с удовольствием вам продаст еще немножко лицензий, на еще чуть-чуть процессоров. Так, мы это записываем, да? Ну ладно. Ну, например, я работал с аппликацией, где баз данных была CPU-bound. Вот так вот. Раз так. А процессор баз данных очень сложно добавить. Аппликационных серверов-то накидать в пул — дело такое. Свистнули нашим продакшн ребятам, нажали пару кнопочек, шеф-папет сработал, виртуальные машины поднялись, нормально. А там физически просто нельзя было купить машину больше, чем это, и процессор заканчивался. С другой стороны, и на самом деле наши ребята, которые занимаются баз данными, сейчас работают над очень интересными проблемами, потому что до сегодняшнего дня с простыми дисками все было IO-bound довольно. Но теперь флаш появился. И теперь bottleneck ушел на самом-то деле в стор-процедуру, и теперь баз данных стали IO-bound, а скейлить все равно тяжело становится. То есть я знаю, у нас есть ребята, которые занимаются SQL, в группе баз данных серьезно занимаются именно оптимизацией SQL как runtime DSL языка, потому что до этого раньше это никогда не было. Это один из примеров. Во-вторых, те приложения для разработки стор-процедур, которые существуют сегодня, и вообще та сложность, и то, что иногда люди пишут в стор-процедурах, значительно сложнее описать, а потом еще и поддерживать. Например, я однажды работал на продукте, где было 1 000 000 строк кода в PL/SQL, где-то в 3500 процедурах. Refactoring is not an option.
Russian, come on.
Не работает.
Что не работает?
Hold on. Окей. Я повторю вопросы, и как у нас со временем? Что-то мы еще есть? Нормально еще? Окей. Вопрос был такой, что происходит, если часто меняется база данных, и вообще, насколько это все сложно, Hibernate туда-сюда, потому что мэппинг надо менять, классы менять. Я расскажу, как мы, однажды у нас есть коллега Гена, который в Торонто живет, который написал нам потрясающий паттерн. Мы на самом деле наши все Java-объекты генерили вообще из баз данных, из метаданных. Просто скачивали автоматически через JSDBC, выкачивали метаданные, генерили все общие parent-объекты, компилировали их, закидывали их в jar, а весь наш домен от них наследовал. Поэтому поменять базу было очень просто. Добавили колонку, нажали кнопочку, все выскочило. Плюс на сегодняшний день, если использовать, если начинать с нуля и использовать что-нибудь типа Spring Brew, то все эти проблемы тоже, естественно, уходят, потому что тул за тебя все сделает. Еще вопрос? Да. Dude, I'm getting good at this Russian thing. The question was, and I'll for Martin.
Yeah, please do this time.
The question was, do you know any database profiling tools? And can we recommend any? We are fortunate enough not to have dealt with that. We have a couple DBAs that work on that, and we love them for that because we do have a couple products that I actually manage one of the products that we've acquired 3 years ago that is CPU bound on the database, believe it or not, tough to scale. And they use database-specific tools, not my specialty, can't help, sorry. Еще вопрос? All right, in that case, we'll defer to Martin to finish the talk in Russian and say thank you.
Thank you.
Oh, come on, you know how to say that. Thank you, guys.
Спасибо.